Okay, in the last presentation with significant figures, I mentioned scientific notation quite a bit. This is a short one. It's only 6 slides, so 5 slides of information to help us along with scientific notation. Scientific notation is a way of writing numbers that are extremely large, meaning a lot of zeros, or very small, meaning a lot of zeros in the decimal places, leading zeros, in a way that's more manageable and a way that we can actually enter them into our calculators. So there's two distinct parts when we write scientific notation. There is a single digit to the left of the decimal place, so it has to be between 1 and 10, meaning 1 through 9. If the answer is 10, we can just leave it as 10. We don't need scientific notation for that. And then after that, we have the times 10 to a power. It can be positive or negative. Keep in mind, positive numbers mean that they're really big, and the negative numbers, when we said we had negative exponent, it meant that it was the inverse 1 over something. So that means it's a very small number. So you can see the value below is 1 million, and when we write that, we want to have maybe 2 sig figs, and that's it. So we write 1.0 times 10 to the 6th. So what does that look like? So scientific notation, when we have numbers greater than 1, we have a positive exponent, so the decimal moves to the left. So you can see in 86,000, we are moving the decimal place 4 places to the left to give us 8.6. We must only want 2 significant figures there, and since we moved it 4 places, we have times 10 to the power of 4, or the exponent 4. The next example is for numbers less than 1, meaning they are fractions, so we have a negative exponent. So the decimal moves to the right when we're counting. So you can see we're moving the decimal 6 places to the right to give us 9.7, and that is times 10 to the negative 6. So the negative number means we have those leading zeros with a decimal. In our calculators, not everybody has the same calculator, so you're looking for a key that has an EE or an EXP either on the button or above the button. Some calculators have a times 10 to the N button. I believe those are the multi-views, and some Casios or Sharps. If you're having problems locating that button, you need to see me so I can help you find it. You may have to hit the second function and that value to get it, and every calculator displays it differently too, so that's something you need to evaluate with your calculator and get help on. Scientific notation, if you don't have a calculator, when we multiply numbers, you can multiply the values that are given to you, the integers that you need, and then you can use your exponent rules and you use your powers of 10. When you multiply exponents, you add them. So we have 15 times 10 to the 10th. That's not proper scientific notation, so we need to move the decimal 1 place to the left. We're making it bigger, so we add 1 more value to the exponent, and we get 1.5 times 10 to the 11th. When we divide, the exponent rule is you subtract the exponents. So here we have 1.5, and we can divide by 3.0 to give us 0.5. But 10 to the 11th divided by 10 to the 8th gives us 11 minus 8 is 3, so times 10 to the 3rd. Once again, that's not proper scientific notation. We need to move our decimal place to the right. And since we are moving to the right and we have a small number, a number less than 1, it would be a negative 1 is our move. So exponent 10 to the 3rd, we have now moving to the right 1, we get the exponent of 10 to the 2nd. So our final answer is 5.0 times 10 to the 2nd. It is way easier to just get comfortable with your calculator or have a calculator that has an exponent button. So that concludes our scientific notation